Doesn't work yet. We'll do that. So I just learned that Silman is getting ready to hit its 50-year mark, making you. Congratulations, 1966. All right. Farnsworth House is a gem. It's one of the most recognized. Yep.
Microphones, are they on? It doesn't sound like it.
Hello.
Okay, that's better.
You guys, okay. I'll stand right here. How's that? Is it clear? All right. It's one of the most recognized and photographed buildings from the mid-century portfolio. This residential masterpiece, designed by Mies in 1945. It's constructed in 1950 to 1951, and it's on the Fox River in the floodplain, about an hour outside of Chicago. The building represents sort of the fully realized emergence of the glass box. It has a clear span interior. And like a ship, it has a lower deck and an upper deck. And the upper deck contains the living space. And when you're within that living space, you feel like you're hovering delicately over the river. Can I see a raise of hands if you've actually been there? So when you're inside, you have this view, and you can see how close it is to the river. And it's the delicacy of the glass, and then the hovering, the elevation of the land, and the proximity of the river that makes it so dramatic and so special. And Philip Johnson, another owner of a glass house, calls this safe danger. But it's the proximity of the river that's causing so much regular flooding of the building. So Mies established the finished floor elevation to height to be 5 foot above grade. And at the time of construction, that was 1 foot higher than the highest recorded flood level to the time. He intended the lower deck to flood occasionally and the upper deck to ride freeboard, exactly as you see in these photographs, with the river swollen underneath it. So the inset is showing the building during construction, and then the larger picture is showing it last summer. Unfortunately, he underestimated the flood mark. The highest recorded flood was in 1996. Water inundated the house by over 5 feet. This image is from 2008 flood. So in the 12 years that the National Trust and Landmark Illinois has owned the site, water has only breached the interior once, but it caused very costly repairs. The previous owner to us was Lord Peter Palumbo, and he owned the property for 32 years. And during his tenure, he had a similar stewardship experience that we're having, which is this constant repair, constant conservation, and constant replacement of the parts. During his tenure, the building flooded twice. We're also dealing with deferred maintenance. The National Trust has no endowment on this property. And in between the floods, we're sort of hoarding our money for a flood event. And in between the floods, we're still dealing with the oxidation of the steel frames around the glass. And then there's drainage issues with the travertine pavers on the decks. The Trust in Landmark, Illinois bought the Farnsworth House at auction in 2003. We bought it for a couple reasons, because it's iconic, because we wanted to emphasize how important mid-century modern is, because the other bidder that we knew of was planning on moving the building out of the way, or out of the state. They're planning on moving it to the East Coast, and we wanted this building to be open to the public. Unfortunately, because there was another bidder, another very wealthy bidder, the bids escalated, and we ended up purchasing it for more than we owned. So we had to take or more than we had. So we took a loan out on the building, and even though we've paid that loan off, this building has no endowment as a consequence. And then the other question we're always asked is how about insurance? So when it comes to insurance, after the 2008 flood, FEMA calls us a repetitive loss property. And so we go off of, the National Trust has insurance for all of our properties together. We leave that insurance plan, and we go through the federal government has a national flood insurance program. So and it was actually very good insurance. So we use them, and then we have additional excess insurance through a private company. Our rates did go up 25% a year until we could establish an actuarial rate, which we were just able to do in the recent studies. So another way to conceptualize how much flooding and how much water is going on this site is to take a look at this Andy Goldsworthy sculpture called Floodstones that was commissioned by Lord Peter Palumbo in 1991. This cairn was situated just on the bank of the Fox River near the Rob Roy Creek, And they're supposed to match the different flood lines. And you can't see it, I can only point to one. You can sort of see the flood lines. Oh, I don't think this is even on. There we go. Can you see these? A saw has come in and shown the flood lines going up. Can you see on that side, there's sort of flood lines right there, all the way going up? So there are 13 of these flood lines. But after the 1996 epic flood, he got Goldsworthy to come back to the United States. He's a British artist. He got him to come back to the United States, and he had to add on to this sculpture. And so by having two scale figures standing in front of it, as goofy as it looks, you can actually see the enormity of the problem and the challenges we asked Bob Silman to design our way out of. That is Edith Farnsworth. I don't think she's thinking about flood mitigation, but we sure are. So we've been thinking about flood mitigation for the last 3 years. And the whole process started when an acquaintance of Edith Farnsworth, a friend of hers and a big fan of the house, walked up to the National Trust President, Stephanie Meeks, and said very bluntly, "What are you going to do about the Farnsworth problem?" Unfortunately, that woman donated some seed money, and we were able to employ it to our initial studies. The first study, we hired hydrology engineers. They were known for their international work on flood-prone cultural sites, and we asked them to quantify the Fox River and to analyze all of the flood data. And what we learned was, so the end of the report was, there's nothing we can do locally to make a difference. There's nothing we can do on the site. There's nothing we can do to the river near the site. That it's a 2,000 square mile watershed of the Fox River. It starts in the Milwaukee suburbs. It comes down past our site. And in 1950, when the house was built, it's 100% farmland, and now it's mostly suburbanized and urbanized. In the next 20 years, it's supposed to have 30% more development. We also hired a geotechnical engineer, and we learned that the water level is pretty high. It's 4 to 5 feet below grade, and that the bedrock is 17 to 20 feet below grade. So let me orient you with the site plan here. The red star is the Farnsworth House. I need 2 pointers. So from here over on both sides is the original parcel. We call that parcel 1. That's what Edith Farnsworth originally purchased. Then she ended up purchasing the second whole piece of land because the highway department did a takings, a combination on her property, and built that big sort of road that's near the Farnsworth House. So they built it on that side. Then with this survey, so the big gray swath is the Fox River, and you can sort of see the bank of the Fox River is past the gray swath, so that's the existing bank of the river, but the Fox River is intended on any day to be anywhere in those points, so that's why it's shown above it. It's called the floodway. And then the 100 and the 500 year floodplain lines are also shown in here, and you can sort of see, oops, sorry. You can sort of see them, they're contiguous for much of the site, and then they separate. So the house is steps away from where the river should be, and the 500 and the 100 year flood line is far away from the house. With all of this information gathered, we then hired Thornton Thomas Study Engineering out of Chicago, and we asked them to just do a feasibility study on everything we could think of as ways to deal with flood mitigation. We ended up with 9 different options, and they put together a report about those 9 options. And then we gathered that material, and we wanted to have a team to help us decide what to do with the information we're receiving. So we put together what we call the Technical Advisory Panel, and it's everybody that's listed on here. And we met at the site to talk about it. And you can see there's people we've mentioned today, and some people in this room are actually on this panel. And Dirk Lohand, who was Mies's grandson, was here. And when we were discussing it and going through the different options, we were able to eliminate some. Like, we were not going to move. The whole reason we bought the house was to leave it here. We're not going to move it out of Plano into Chicago or out of the state. So we were able to eliminate some of them. And then we had a pretty deep discussion about a hydraulic lift because Dirk had proposed that because he was the architect for Peter Palumbo when Peter Palumbo was dealing with it. So after we had all of these discussions about the lift, the team decided to look inward and to hire Robert Silman to pick the top 3 different options we were looking at and to further develop them.
Oh, look at what climate change has done. If you don't believe in it, believe it, okay? So we were asked to look at the 3 most promising options from the original 9 in the report. The first was option A. That would keep the house in the same location that it was originally, but raise the grade high enough, some 8.5 feet, so that it would be above the 500-year floodplain. Now, there were several ways to do that. You could build a little knoll and put the house on it. That wasn't seemingly satisfactory. So they would try to grade it out so that it still looked like a farm field, and it meant bringing in huge quantities of fill. All the trees, of course, would be lost, but it was a possibility of doing this. Now, of course, in order to do that, you'd have to temporarily move the house to a location outside of the fill area and above the floodplain, presumably, demolish the existing foundations, fill all around it, and then build new foundations and put the house back. This would preserve the proximity to the river, which is very important. You know, we had a technical advisory meeting in the house, and I found my eye wandering to the river, and you could see little pieces of bark floating in the river. You could see the bubbles in the river. It was mesmerizing. You're that close. You're about 95 feet away from the river at this house. But it would have elevated it some 8.5 feet. And, you know, looking down that much, it would be quite a different experience. In addition, of course, it would change the landscape completely. Option B was to relocate the house up the hill to higher ground. Now, to get above the 500-year floodplain, if you can see the middle picture there in option B, you'd have to be some 500 feet back from the river rather than the 100 or 95 feet that we were presently. So that would change things dramatically. You couldn't see the little pieces of bark. You couldn't see the bubbles from there. It wouldn't change the landscape, however. What was in front of you would be the same landscape, but it would dramatically change the location of the house, putting it right near the road and subjecting it to road noise. And the notion of being in the middle of the farm field, very close to the river, would be totally lost. However, of course, the house would be preserved. Obviously here, the house gets moved also. In fact, in any option, the house has to get temporarily moved or permanently moved. Option C is a mechanical option, where some system would be employed that would lift the house up during a flood. The flood would happen, go away, and the house would come back down. So when there wasn't a flood, you would see the house in its original position. You wouldn't know anything was there because all of the mechanism for this would be underground. When there was a flood, of course, people wouldn't be at the house. It's a crisis period. It loses its historicity, obviously. It's up in the air. You know, I think if Mies had known what climate change would do, he might have designed the house either in a different location or higher or whatever. But we're stuck with this now, and the notion of leaving the house as it was 99.5% of the time or more was very attractive to the technical advisory panel. And they did latch onto that one option as the one that to be involved more thoroughly. Dirk Lohan, Mies's grandson, pointed out that many years ago, in 1967, when they built the new National Gallery in Berlin, they lifted the roof with hydraulic jacks. The notion of using hydraulics in building technology is not unusual. The notion of using hydraulics in any technology is not unusual. Every day you get into your car, that you put your foot on the brake, that's a hydraulic system. Every time you fly in an airplane, everything that works mechanically is hydraulic. In big movable bridges, these bascule bridges or swing bridges or lift bridges, those are all operated hydraulically. They all work. We depend on them. It's not some new technology. In fact, when you take your car to the repair shop, you drive onto the lift, somebody pushes a button, voila, your car goes up in the air on a hydraulic lift. So this is not anything new. Hydraulics is something that is all around and people understand it. The exact system that we designed, first of all, involved moving the house. You have to get it off its present site, temporarily up the hill. There are some places it could have been stored temporarily, obviously above the floodplain in case a flood occurs while you're working on the house. Demolish the existing foundations. And then the notion was to dig a pit under the house. That pit would contain all of the hydraulic mechanisms. It's not hard to dig a pit. The pit would be below groundwater, but again, many building basements are located below groundwater. We know how to do that. Instead of having, like your garage, a cylinder that goes straight up in the air and lifts your car, we felt that that was not the right way to do it. Because if we put, there are 8 columns that we had to lift. If we put a jack under each one and pushed a button, they all went up in the air, each one of these things would be a separate cantilever. And there's a lot of lateral force in a flood situation. You know the currents push sideways. A lot of wind usually happens because it's a stormy time. These jacks are not meant to take lateral force to act as cantilevers. There's a seal in them that holds the oil, and every time you move it sideways, the seal gets stressed and the oil wants to leak out. That's not desirable. The manufacturer is warned against using them that way. So we designed a different kind of a system, which used a set of vertical linkage trusses. In the middle picture, which is called the down position here, you see 4 turquoise trusses that are lying flat. They're lying on the top of the pit, and they're connected to these yellow things, which are the hydraulic jacks, or we call them actuators. And there are 2 per truss, so there are 8 actuators pushing these 4 trusses. When the warning for the flood comes, the superintendent out at the house pushes the button. The jacks work by pushing these trusses up diagonally until they're in a vertical position, and I'm going to show you this later on in a video. And the trusses go from being flat to being vertical, and they raise the house by 9 feet. Now, there is a platform on the top of these trusses that links all 4 of them together, like a big concrete slab, and the house is resting on that slab. So when you raise the slab, you raise the house as well. Of course, you have moved the house back onto it. When the building is in the down position, you don't see anything. This is the house, I'm sorry, the site has a dirt area around that. There's no grass because it's under the house. And there are 2 thin steel curbs that come together. And when the house is raised, one goes up while the other's fixed. When it's down, they're just below grade, and you can rake soil over them. So there's nothing visible about what will happen when the house is down. When the house goes up, of course, it's a different story. The notion of the house being tilted up, when it's in the up position, all of the lateral forces are taken by the trusses, not by the jacks. Now, in the diagonal position, they can take inline forces, but not laterally, because the trusses are much stiffer than they are. Also, all of the load is in the trusses. You can relax the pressure in the jacks if you want to, in the actuators, because all of the support is in the 4 trusses now. So this is another feature. The controls would be in a waterproof cabinet somewhere in the pit. There would be an electric emergency generator, obviously, in case the power failed. That could be up by the road, by the house. So there are many ways of handling all of the controls for this. There are many different kinds of controls. The particular one that's most important is the one that keeps the jacks in a unified working order, so one doesn't push harder than the other. This is a system that's, again, well proved. When we move buildings with unified jacking, so that the thing as it's going down the road knows how to adjust for a pothole or an elevation change. We know how to do this. There are feedback sensors that change the pressure in the jacks. Not very sophisticated, as a matter of fact, commonly used. This is a system that can be tested. You don't have to have a flood. If you want to know if it works, you have a test. You push the button, the house goes up, the trusses go up, you see if it works. If it doesn't work, and maybe you test it 3 or 4 times a year, it was my suggestion that you increase the visitor fee that day so people can see it. Okay. You test the house, and if anything is wrong, you have the opportunity to fix it. Who fixes it? A hydraulic mechanic. They're all over the place. It's not some guy you have to get from NASA. This is not rocket science. This is hydraulics. Easy to do. It's off-the-shelf components. Hydraulic rams are done all the time. These are not huge, oversized things. The amount of force in them is not something that's out of the ordinary. It's designed to be single-point failure proof. How's that? Okay. If any one item fails, the whole system does not fail. This comes from things like Disney World. All of the stuff at Disney is hydraulically powered. The rides, the bridges that move over the canals. There's hundreds of thousands of people walking around these things, and they have to be damn sure that they don't fail. And the science of doing that is reliability engineering. And again, something we do all the time. Movable bridges, the same way. There is a lot of precedent for this kind of a thing to happen. The reliability of it, in our opinion, is not under question. It's not something that's never been done before, never been tried before. Maybe not in this application, but the equipment for it is something that's commonly used. The concrete pit, the exact configuration hasn't been decided because we haven't designed this thing yet, other than a preliminary. But you can see in the upper picture, there's a pit, in this case sort of a U-shaped thing. That has one part has to be deeper than the other. But you can walk around down there. It's probably about 8 feet high, 9 feet high. And you can see what's going on to service it. The cover is in the bottom picture. You can see a concrete cover on it. And the jacks and the trusses are under there. And when it lifts the concrete cover. What isn't shown here is that the house is on top of that, and then there's a layer of earth. So that all gets lifted together. Is there precedent for this? Certainly. I talked about movable bridges. Here's a really sexy one in Greece, 1988. This is a bridge that is over a canal that has very large ships that are high. And to build a road that went over the top would have meant destroying the landscape on both sides. So what did they do? Where's the bridge? What happened? It's in the water. It goes down, not up. So people say, these systems don't work underwater. They don't. This bridge has been in operation since 1988. It works absolutely fine. This equipment is, it's very durable, very rugged. This bridge is used daily several times. It goes down. We're talking about something that's seasonal, or really it's going to be operated for testing. This is in the halfway position where you see the roadway, the two roadways coming up out of the water or going down in the water. These systems are used all the time. Ashley.
All right, so Bob's pretty convincing. We all thought it was a really cool idea. We loved it. Not all of us. Us inside the National Trust liked it. But we knew we needed some people to peer review it because I don't know if somebody needs to interrogate this report and tell us if the engineering works and if there's any unforeseen conditions. So we had this group of technical peer reviewers on the top, and then we also had these sort of one-on-one conversations for over an hour with many of our preservation partners, and many of you are sitting in this room. Thank you very much. Within the technical advisory panel, it was split. More people liked the hydraulic system, but there was 2 that still had reservations. And then we decided that because the Chicago architectural community is so engaged, we're going to do a road show. So we went to Chicago actually 5 times. We had 2 meetings for professionals, architects, engineers, preservationists in different places. We had 2 public meetings, one at Plano, one at IIT Crown Hall, and we met with our easement holder. And while mostly there was support for the hydraulic system, there was some loud and vocal opposition against it. What we did learn from the feedback is we need to do a couple more studies. The first one was really obvious, but we just didn't have time to do it because of the organic growth in this project. So we had to do a preservation plan to figure out what we're going to be doing with the building this whole time. And we needed to better understand the landscape. So we needed a cultural landscape plan. And this is the team that's currently working with us right now to do these 2 things. The big thing that we learned is the significance of the NHL is pinpointed in 1951 only. But Peter Palumbo has this property for 32 years. Edith Farnsworth has it for 20. And she had zero management. She built the house, she drove her car on the contractor's drive to the house, parked in front of the house between the house and the river, and got out, and that was it. Peter Palumbo was a steward. He created the gardens that you see today, and he created this walk and all of the screening from the highway. So one of the things that kept coming up in these conversations was, why not buoyancy? So Bob's going to speak about buoyancy quickly.
So one of the obvious things that must have occurred to you is, why not let nature do the work? You've all been out on a floating dock somewhere, and if you've ever looked underneath it, there's either big blocks of styrofoam or 55-gallon drums that are sealed or some kind of a tank. So it's like a boat. It displaces the water and it floats. Why not, when a flood happens, dig a pit. When a flood happens, if you have buoyancy attached to the underside of the slab in the pit, the water will raise the house up. And when the flood is over, it'll go back down again. It sounds simple. In fact, somebody made a little model at one of our presentations of the Farnsworth House in Lego on a little piece of cardboard and in a pot. And under the house were 3 empty water bottles, you know, what you drink from. And he poured water in there, and the house went up. Well, you know, in my mind as an engineer, this proved that if you pour water in a pot and there are 3 empty bottles in it, they'll rise, okay? So sure, this is a very nice romantic notion of how to make it work. And oh, that we could do that. In fact, if you know what's going on in New Orleans now with the shotgun houses, these schemes are being proposed. And indeed, at that level, they work, because the shotgun houses are rough and ready, and they don't have nearly the requirements that this has. But here are some downsides to buoyancy. There's no way to test it. It won't go up in the air until there's a flood. So how do you know it's going to work? Supposing it needs a guidance system, first of all. That other picture we showed didn't have a guidance system. But it's got to have something. The shotgun houses, they drill 4 telephone poles in that are sticking up in the air and put rings around them and attach rings to the house so it doesn't float away. When it raises, it stays there, and when it goes down, it roughly comes back to the same place. But again, you can't test it. We have nothing that we can have up in the air. Any guidance has to go back down in the ground. So you could have telescoping poles, presumably, that might be able to do this. But again, when they are subject to lateral force, they move a little bit. It's quite tricky. So, as I say, no mechanism for testing, and you can't inspect it, so you don't know if over the years something freezes in there, something rusts or corrodes on the guidance system. The buoyancy tanks develop a hole, they corrode. We don't know. When we have a flood, one of the issues is going to be, after the flood, it isn't so clean. It's not just water. You all know what floods bring with them. Debris, mud, gosh knows what, dead frogs, whatever. They're going to go down into the pit, and you have to clean them out. This has no mechanism for doing that, because the only thing holding it up is the water, and when the water goes away, the house goes back down on top of all that crud in the pit. You can't get at it. It's, I don't know how you do that. In order to do that, you'd need some sophisticated control system. But the other thing is, you don't want it to rise in a minor flood. There are many floods that may be a foot and a half. That's fine. The house is safe. It's already 5 feet up in the air. But this would start to raise immediately. And so you want to have a mechanism so it doesn't. We could do that. We could put an intake scoop for the water somewhere above the grade. As soon as you start to do that, what if the scoop clogs up? What if this is happening during a period of ice? What if debris gets in the scoop hole? There's a lot of stuff, a lot of ifs here that we worry about. The guidance system, we're already over our time, aren't we? Okay, so all these things are what's wrong with buoyancy, and there's no precedent for this kind of thing. The rapid accelerations that might drop, et cetera, et cetera. Buoyancy didn't work.
So one of the options that was brought up to us, I'll be quick, is to actually move it to the farm field. And we had never looked at that. We had looked at moving it up on the site farther away from the river. And there's a lot of compelling arguments about this, but one of them is the house would actually be closer to the river and be farther from the road. And because it's a farm field, there's nothing there, so you could create an appropriate setting. And so we're calling this sort of the move it and done philosophy or alternate. And it does give you the ability to interpret the old site. So the old site, which has the Peter Palumbo layers on it, you could build basically sort of a ghost platform where the house is at the same size, and you could stand there and understand the flood history and understand Farnsworth House in its old location, and you'd still have the preserved farm field house in the new location. And then you can see the location that it's in is very compromised in the sense that you have this huge highway going by that's very loud. It took 2 acres of her land. She actually sold the property once that highway went in there. She fought it in a legal battle. And the house was situated under a black sugar maple, and that's not there. So you have to look at the integrity of the original site doesn't have what it used to have for the reason that it was built there. So we're looking at that with the farms scheme, and we're going to come back to this. So I'm going to come to, when it comes to the criteria, we have no solution. We have these 2 schemes that we think are very viable, and we've come up with criteria that these schemes have to pass to get this thing built or moved or preserved. And the first one, which is thanks to the Park Service for helping us see this so clearly, is doing nothing is not an option. We have to do as stewards something with this building. So the schemes have to fit that. It has to meet the Secretary of Interior standards. I put preservation there subliminally because that's how the National Trust looks at this property's preservation standard, but our easement just says the standards, it doesn't say which one. It can't jeopardize our NHL landmark, and here's the kicker, it has to be approved by Landmark Illinois. Here's the easement holder on the house. And the unwritten criteria that I didn't put up here is a donor has to be able to buy into this and pay the money for it. We did have a donor who was behind us originally, but once there was local and loud support, they've sort of sat back for a while. So right now this is unresolved, and we will end with this.
So we're done, except let me show you a wonderful animation, if I can figure out how to do that, okay, of what the hydraulic scheme would look like. Push the button. I just did. Up, up, up. Flood is coming. All right, it gets. I got to do this. I'm always tapping the wrong thing here. All right, they push. The flood alert comes, and they push the button, and the house goes up. And it's literally the push of a button. And you can see those turquoise trusses going up in the air. Nope, I keep doing the wrong thing. All right. I'm trying to stop it up in the air, and if I can't do that, I won't. Yeah, put it back down on that thing. Okay, I know. I don't want to lose that thing. Okay. Okay, so it didn't stop, but all I'm saying is that what happens is it stays up in the air for that period of time that you need to clean out the pit, and it could be days, it could be weeks, whatever it needs to be while it's up there. And you clean it all out, and there's this opportunity to work on it. It could be done for maintenance reasons, or it could be done after a flood. But the idea is that it's controllable, and this is something that it's not dependent on nature. Is it going to work this time? Yeah, okay. So you can stop it anywhere you want, but you stop it when it's all the way up and the load is in the trusses. And now you have all the time in the world to work on it. This is the value of this scheme, and that's it. Okay? Very good.